The annual yield per walnut tree is fairly constant at 50 pounds per tree when the number of trees per acre is 30 or fewer. For each additional tree over 30, the annual yield per tree for all trees on the acre decreases by 1.5 pounds due to overcrowding. In Part A, we're asked to express the yield per tree, Y, in pounds as a function of the number of walnut trees per acre, X. And in Part B, we use that information from Part A to express the total yield for an acre, T, in pounds as a function of the number of walnut trees per acre, X. So we need to determine how to write a function with our given information. Now we're told if we have 30 or fewer trees that the yield is 50 pounds. So we can write our function y, and we'll write it as y of x since it's a function of x. We have two different possibilities. It's going to be a constant of 50 pounds if there are 30 or fewer trees. So if x is less than or equal to 30, our yield is 50 pounds. And then we're given some more information that says for each additional tree over 30, that annual yield decreases by 1.5 pounds for every tree, including the first 30. So we start with our original 50, and then we decrease that by 1.5 pounds once we go over 30. So we have to write x minus 30 so that this allows for any tree over 30. So this is if x is greater than 30. So here's our piecewise function that expresses the yield per tree as a function of x. Now in Part B, we're asked to express the total yield T as a function of x. So we'll have T of x. In this case, we simply, in order to get the total yield, we take the yield per tree and multiply it by x, the number of trees. So T of x for the first part of our piecewise function will just be 50 times x if x is less than or equal to 30. Now, we need to multiply the second part of our piecewise function by x as well, but it's a good idea to simplify it first. So in order to simplify it, I'm going to simplify it down here. And I'm going to write y of x is equal to, I'm taking this line that I underlined in blue, and I'm going to simplify that. It's 50 minus 1.5x when I distribute. Negative 1.5 times negative 30 is plus 45. So therefore, y of x really equals negative 1.5x. 50 plus 45 gives me plus 95. That's whenever x is greater than 30. So I'm going to take this simplified form right here, and I'm going to substitute it in here for my total yield, and I'm going to multiply it by x. I'm going to have negative 1.5x plus 95 times x if there are more than 30 trees. So if x is greater than 30.